Good, how are you?
Good. Okay, so we don't have any specific material to work on tonight, right?
Yeah, I was having testing all week.
Okay. The TCAPs?
Yeah,
Okay. How fun are those?
not so fun.
Oh, that's what everybody tells me. They're not very much fun. In fact, in Illinois, they're protesting. All the teachers got together and protested even having them. And parents. They had like 600 parents sign up saying they didn't want their kids taking them. But it's the way they get their money. It's how they determine how much each school gets is by the performance of the students. Anyway, I don't have a lot in the way of Algebra 1 material just because I don't tutor a lot of Algebra 1 students.
Okay.
So I don't have a lot, but I do have this, Big Ideas Learning. Are you familiar with this site?
I think so.
You may use something like it or have used something like it over the years, but let's go to Algebra 1 and let's take a look at the chapters and tell me of these, what do you recognize? In other words, I don't really know what you've done and what you haven't done in class.
Okay.
You've done exponential equations, I believe.
Yeah, I think so.
So you're probably going to be on polynomial equations and factoring.
Yeah, that's what I'm on.
Let's do those. All right, multiplying polynomials. Let's look at their quiz and see if we can just do some problems here. To add polynomials. So this is stuff that looks familiar to you? Multiplying and adding polynomials? I'm not sure I want to get ahead of what you're doing, but maybe. I don't want to get too far ahead.
I don't know. Is this where like you times like each of the things?
Yeah, adding and subtracting polynomials is quite easy. Here, let's do it. You're going to have to tell me whether this is stuff that's more advanced than you've been covering in class or not. So let's take the first one. 2x squared plus 5 plus... Now notice I didn't write the parentheses on the first term because it's not really necessary on that term. It is necessary on the second term. So our first goal is to get rid of all the parentheses. So what am I going to write next?
1x squared plus 9.
So that's the answer.
Okay.
So it's real easy. Let's do another one that looks a little tougher. How about this one here? Do it step by step if you would, so that I know if you do make a mistake, I'll spot where you're making it instead of just giving me a final answer. So remove the right parentheses. I can, like I said, I can remove the left parentheses without doing anything.
Mm-hmm.
The right one, what's going to be left?
I don't know.
You have to distribute that negative sign to both terms.
So, do I multiply or?
So minus 2n squared minus 7.
Oh, okay.
You do multiply it, but you're really multiplying by minus 1.
Okay.
Now simplify.
Negative 5n squared plus negative 7n.
Plus n minus 7. In other words, you can't combine those two. That's an apple and that's an orange. You can only add like things. It's the same reason I cannot add n squared to n, because they're different things. If I had a 5n squared and 2n squared, then I'm going to have 7n squared. I can add stuff that is similar, but it has to be similar. All right. Let's go down and talk about multiplication. You've learned FOIL?
I don't think so.
Really? Well, it's not going to hurt you to get a head start on this stuff. This is probably going to come up very shortly in your class. There's an expression called FOIL. What it stands for is first, outside, inside, last. When I multiply these two binomials together, the first thing that I'm going to write is the first terms multiplied together. What's W times W?
W squared.
What's the outside things multiplied together?
42.
No. That's outside and that's outside.
Oh, 6W.
7W.
Oh, so yes.
What's the inside? This times this.
6W.
And what's the last? That being 42.
Yeah, 42.
So now simplify. How many W squareds are there?
1.
How many W's are there?
13.
How many numbers are there?
42.
There's the answer. Now,
Okay.
I'm not terribly fond of FOIL because it doesn't work when you have 3 terms times 2 terms, right?
Yeah.
In other words, there's no first, outside, inside, and last if I've got 3 terms times 2 terms. So I use what I call ET, which means every term by every term. So the first one I'm going to start with is the term on the left. I'm going to multiply it by that, and then I'm going to multiply it by that. And then I'm going to take this term and multiply it by that, and multiply it by that. In other words, I'm going to take every term and multiply it by every other term, which would work really good if I had problems like this. If I go to multiply that times that, FOIL isn't going to do me much good. But every term by every term works for everything. And I'm always going to maintain the same pattern. In other words, I'm going to start with the first term, multiply it by the first term. First term times second term. First term times third term. Second term times first term. Second term times second term. Second term times third term. Add all of those together.
Okay.
So I prefer to call it ET rather than FOIL, because it works just as well on 2 terms times 2 terms. You're still multiplying every term by every term. So let's do this one. What's the first term by the first term?
Y squared.
What's the first term by the second term?
Y minus 3.
Minus 3y.
Minus 3y.
Second
9y.
term plus 9y. Remember, we need the signs when we're inside of an expression. If I leave the plus sign off there, I'm in limbo. I got nothing. I don't know what I'm doing with it.
Yeah. And then negative 27.
Now simplify.
Y squared. 6y.
Plus or minus?
Plus. Minus 27.
I can leave the plus sign off of this y squared. I don't need it. But I need the plus sign in front of that 6y. If I left it off, it wouldn't have any meaning. I don't know what that means. So the plus sign tells me I'm adding it.
Okay.
Okay. So is this stuff beyond what you've done in class, or is this...
I think we've done like this.
Okay.
But he didn't call it FOIL.
Okay. Well, maybe good. Maybe they're getting away from using that term. There's nothing wrong with it, and it works fine as long as you're in Algebra 1, but by the time you get to Algebra 2, you're going to be multiplying 2 terms by 3 terms. So what's this?
D squared minus 5D minus 2D plus 10.
Simplify.
D squared minus 7D plus 10.
Okay. I think you got that down pretty good. You know how to do that. All right. How about number 15? Whoa. Just a second. The computer got all funny. So 15 is t plus 5 quantity squared. First of all, that's the same as this. Right?
Oh, okay. So is it 2t?
No.
T squared?
Uh-huh.
Alright, t squared plus 5t
Uh-huh.
plus 5t plus 10t.
Okay.
Plus 25.
Yeah. Okay, good. You got those down. Let's see what other kind of stuff they have in this chapter. This is a... What is the degree of this polynomial?
I don't know.
The degree of a polynomial is the exponent, the highest exponent.
Okay.
So it's 3. What's the degree of this polynomial?
2.
How about this one?
6.
And this one?
4.
Okay. Alright, that was the quiz. 147, let's go on. Solving polynomial equations in factored form. Let's take a look at what they are doing here. Well, let's talk about factoring. No time like the present. This is something that everybody hates, but that's because they teach you this crazy method in school of how to do these, called the California method or the diamond method, or are you familiar with those words at all?
No.
Okay. Notice that we're looking at the quadratic that we produced when we kept multiplying those binomials together, right? We ended up with an x squared term, some number of x, and some number. So what we're going to learn to do now is to factor the quadratic into 2 linear terms.
Okay.
Follow my reasoning here. There's 3 very critical steps that you want to take every time you do this. The first thing is to figure out what goes there and what goes there. What is going to produce x squared?
X times x.
Yeah. So that goes there, that satisfies that. That's step 1.
Okay.
Step 2. You might want to write these down, because if you can memorize these steps and always use them, it'll be so valuable to you. Everybody else will be cursing factoring, and you'll love it, because it's not that hard if you remember these steps. Step 2 is to examine the sign on the constant term. In this case, that's negative.
All right.
The only way you can produce a negative constant is if the signs are opposite. So, step 2 is to write what my signs are.
Minus, plus. Okay.
Step 3. I want factors of the constant, factors meaning two numbers that multiply together to produce 2. Well, what's that? That's 2 and 1. That's it. So I want factors of 2 that subtract, because of that negative sign, to the coefficient of the middle term, which is 1. 2 and 1 satisfy that condition. 2 and 1 subtract to 1. Now, I want to take the bigger of those factors and put it on the sign of the middle term. So the 2 goes there, the 1 goes there. That's how you factor a quadratic and take it apart. Now, just to check, let's multiply these two things back together. We get x squared minus 2x plus x minus 2, which is x squared minus x minus 2. That's what we started with. That's what we want.
Okay.
Okay? So, let's practice factoring, because you can never do enough of that. Let's factor some of these expressions they have here. Let's take this one here. X squared minus 4x plus 3 equals 0. The reason we're going to factor them is because I can solve it. If I get two things multiplied together equaling 0, I know how to solve for x. If I get a quadratic equals 0, I don't know how to solve for x. I don't know what x makes this true. But if I get x minus something times x plus or minus something else, then I can solve for x. So step 1 is what?
You multiply the ends?
Always, that's step 1. We have to make sure that these two multiply together to give you that. In other words, if that was 2x squared, then one of them would have to be 2x and the other x.
Yeah.
Your goal is to make sure these two things multiply to give you that. That's step 1. Step 2, examine the sign on the constant. What is it?
Minus.
There,
Plus.
3 is the constant.
Okay.
Okay? The fact that that's a plus means both signs have to be the same. They either have to be minus minus or plus plus, because that's the only way I can produce a plus. Right?
Yeah.
In other words, if it was plus minus, this would be minus. So it can't be plus minus. It's got to either be plus plus or minus minus. This tells you which. Because this is minus, then it's got to be minus minus.
Okay.
Third step and final step is what? Factors of 3 that add, not subtract, add because of that plus to the number 4. Well, what factors would that be?
1
and 3.
Okay.
Notice that that works. That gives me minus x when I multiply the inside. It gives me minus 3x when I multiply the outside. I add those together. That's my middle term. That's the only term I really need to check. In other words, I did all of this factoring based on the fact that that term was correct and that term was correct. So I don't need to check those once I'm done. But I do need to check the middle term. The middle term is important to check, because if we're going to make a mistake, it's going to be in that middle term.
Okay.
All right. Let's try this one. X squared minus 5x plus 6.
So you put x in both of those, and then it is a minus on both of them, and then
Say it out loud. What are we looking for in step 3?
like two numbers that add to be 6.
No. We're looking for factors of 6. That means two numbers that multiply to 6.
Oh, okay.
And add to 5. So what two numbers multiply to 6 and add to 5?
3 and 2.
And notice that it doesn't matter whether I put the 2 there and the 3 there or vice versa. I'm going to get the same. Okay? Now, if that's all equal to 0, the whole point of factoring is because now I have a way to solve that. If you tell me that one number times another number is equal to 0, I can tell you that, well, one of those numbers has to be 0 then. There's no way you can multiply two numbers and get 0 unless one of them is 0. So the way I solve this is I set that equal to 0, and I set that equal to 0. So I have x minus 2 equals 0, which gives me a solution of x equal 2. And I have x minus 3 equals 0, which gives me a solution of x equals 3. So those are my two solutions, and I only got them by being able to factor this quadratic.
Okay.
Okay? So factoring is a very useful, valuable thing to be able to do, because you're going to run into nothing but problems over the next 4 years where you have a quadratic equal to 0, and you have to solve for x. And the only way to do it is by factoring. So let's make these a little harder. Let's do one more easy
one. Is it a minus and a plus?
Yep. You know the signs have to be different.
Yeah.
Now, out loud, tell me what the third step is.
Find factors of 3
That do, not that add.
that multiply to be.
No, you read the sign.
Oh, is that subtract?
That subtract to the number 2. Not to minus 2, just to the number 2. It's as simple as that. Well, factors of 3 are 3 and 1. Those are the only factors of 3.
Yeah.
They do subtract to the number 2.
Mm-hmm.
Where does the 3 go and where does the 1 go?
I think the 1 goes first.
Yeah, the larger factor always goes with the sign of the middle term. The sign of the middle term is negative, so the 3 goes there, the 1 goes there.
Okay.
Okay? So far, so good, right?
Yeah.
All right. Let's change it up a little bit. Let me think for a moment. That's 2x squared minus 6x plus x minus 3. So if we started with that, can we factor it? 2x squared minus 5x minus 3 equals 0. Now, this is altogether different in terms of the rules and sayings and expressions and everything I can say about this.
Okay.
What goes here and here?
2x and 2x.
Does that multiply to give you 2x squared?
I think.
No, it would give you 4x squared.
Oh.
You have to multiply the 2's and the x's. So it's got to be 2x and x.
Okay.
This multiplies together to give you 2x squared.
Alright.
What are the signs?
Plus and a minus.
Yeah, only in this case, that is not exactly the same as that. Every case we've looked at so far had the same coefficient in front of the x. And if you have the same coefficient in front of the x, whether it's 1, 2, or 3, then plus minus is the same as minus plus. But if you have different coefficients, you have to consider both possibilities. Okay? I can also now no longer make statements like factors of 3 that subtract to the number 5. All of those go out the window the moment the x term has a coefficient. Okay? So forget all of those expressions I just taught you. They only work when it's x times x.
Okay.
As long as it's x times x, then everything I've taught you so far is true. But the moment you have a different coefficient in one of them, then it becomes kind of trial and error. What are factors of 3? I don't have a whole lot of choice here. 3 and 1. So at this point, it's trial and error. I just try 3 there and 1 there. What does that give you as a middle term? To get the middle term, just multiply the insides together and the outsides together and add them together.
So 3x.
That's the inside.
Okay, and then 3 minus 3x.
What's minus 1 times 2x?
Minus 2x.
Add them together.
1x.
Is that our middle term?
No.
So that's not the right answer.
Yeah.
Back to the drawing board. Let's try 1 here and 3 over here. What's my inside smiley face?
1x.
My outside?
Minus 6x.
Add them together.
Minus 5x.
Bingo, we have an answer.
Okay.
I've checked it. I know the answer. I can erase that minus and that plus. My answer is 2x plus 1 times x minus 3. So what's my solutions for x? How do I now solve for x?
Equal it to 0.
So 2x plus 1 equals 0. Solve that.
3x.
No. Isolate the x. In other words, once you get an equation down to where you have a variable and some numbers, put the numbers on the other side, leave your variable on the left side.
Oh, so
we're solving a linear equation here. When you solve linear equations, you leave the variable on one side of the equation, you put the numbers on the other. Different than solving a quadratic. Solving a quadratic, you put everything on one side and 0 on the other. So the next step here is 2x equal minus 1, and what's the final step?
Divided by 2.
So x equal minus 1/2. There's one solution. What's the other solution? Remember, quadratics usually have two solutions.
Okay, x minus 3 equals 0.
Which means x equals,
3.
there's my second solution.
Okay.
Okay? Now, I need to get my algebra book out because it's hard for me to make up quadratics that factor perfectly. You know what I mean? I don't know how to do that. I had to multiply those two answers out in order to come up with that quadratic there. So let me look in my book and we'll just work on solving quadratics. Solving quadratics by factoring.
I'm actually going to go to the bathroom real quick.
Okay.
Alright, I'm back.
Okay. Alright, I have some quadratics out of my Algebra 2 book. Don't let that frighten you. All quadratics are pretty much quadratics, whether you're taking Algebra 1 or Algebra 2. So, hold on a moment. Alright, let's try this one. Start me.
X and X.
Times.
Plus and minus.
And notice I don't care because x's have the same coefficient. Plus minus is going to be the same as minus plus.
Yeah,
The third step. Say it out loud.
5 and 2 are the
No,
numbers.
say it out loud. What do we need? Factors of 10 that do what?
Factors of 10 that subtract to make 7.
Yeah, exactly. Factors of 10. Well, let's write out the factors of 10. That's it. Do we have factors of 10 that subtract to 7?
Yeah,
What?
5 and...
Those add to 7. They don't subtract to 7.
So,
That
is one of them negative?
No, what this tells us is that we cannot solve this by factoring. Not all quadratics are going to factor nicely. In fact, most do not. We deal with a very special class of quadratics when we teach factoring. We generally give quadratics that factor. The only reason I gave you this one is I wanted you to see that not all quadratics have a nice, pretty solution. This is one that does not. Well, there still is a solution to that quadratic equation. There is some value of x that makes this true, but you have to use the quadratic formula. I'm going to give it to you. I don't expect you to memorize it. I just want you to be aware of what it is.
Okay.
Where A, here's the quadratic form. So when I'm solving a quadratic, I'm looking, A is my coefficient of my x squared term, B is the coefficient of the x term, and C is the constant. So just for the heck of it, let's plug it in and see what the answers to this quadratic really are. What's minus B?
What?
What is minus B? B is that, minus 7.
Okay.
So what is minus B?
Is 7?
What's B squared?
7 squared?
49.
Okay.
Minus 4 times A, what's A?
X squared?
It's 1. It's the coefficient of the x squared term.
Oh, okay.
Times C, what is C?
Negative 10.
All over, what's 2A?
X squared?
No, what's, A is 1.
Oh, so 2.
So, notice what kind of answer we have. We have an answer. 49 minus a negative 40 is 89, all over 2. There's my answer, what x is equal to. X is equal to 7 plus root 89 over 2, and x is equal to 7 minus root 89 all over 2. There's my two answers. They're not pretty, but they work. If I substitute those answers in for x, this equation will be true. X squared minus 7x minus 10 will be equal to 0 if I let x be either of these answers. Okay? So that is the process you use when you have a quadratic that can't be factored. You have to resort to the quadratic formula to solve it. Now, you're probably still a year away from learning the quadratic formula, although I wouldn't doubt that they'll at least expose you to it quickly. And that's all I wanted to do, was expose it to you so you'd know what it means when you can't factor a quadratic, like we couldn't factor this quadratic here. If I can't factor it the normal way, doesn't mean there isn't a solution. It's just the solution's much harder to get. Let's make that a plus 10.
Okay.
Now factor it for me.
X and X.
Sign. What are the signs?
Is it 2 minuses?
Yes, it's minus, minus. Okay, that's step 2. Don't get ahead of yourself. Now what's step 3?
Do you want me to say it out loud?
Say it out loud. I would like you to do it because
factors of 10 that add to make 7.
Okay, what are those going to be?
5 and 2.
Perfect. Just by changing the sign on that 10, I have made a quadratic that could be factored easily.
Okay.
Okay? All right. Let's go back and do some quadratics that aren't x and x. Because when it's x and x, that's pretty easy. I think you know how to do that. Yeah, let's talk about one other kind of quadratic, first of all. about when we have a quadratic that doesn't have an x term. First of all, let's define what polynomial means. That's a polynomial.
Okay.
That is not. That is not.
Okay.
That is not. Polynomial has to have the variable on the line, not in the exponent. That's why that's not. And it also has to be a whole integer. Can't be fractional or square rootish. So we define polynomials as a series of x variables raised to some exponent. So maybe the full polynomial might be that. That would be a polynomial of the fourth degree. So, if I have this is a polynomial, but it's not, and it's also a quadratic. It's a quadratic because it has an x squared term. But it doesn't have an x term, which means I'm not going to factor it like I would normally factor. The stuff I've been showing you is not going to work here. However, I can still factor this. This is called the difference of perfect squares, because that is a perfect square and that is a perfect square, and they're being subtracted. Okay? If I have the difference of perfect squares like that, a squared minus b squared, it always factors to a minus b times a plus b. That's something you want to memorize. It's called the difference of perfect squares. It always factors to that. Well, notice what I have here. I have the difference of perfect squares. Well, what is a going to be? X.
Yeah.
What is b going to be? 4. In other words, the square root of that is x, the square root of that is 4. So this factors into x minus 4 times x plus 4.
Okay.
Which helps. It's really easy, for one thing. If you recognize you're looking at the difference of perfect squares, it makes it really easy to factor, and now it's really easy to solve. What are my two solutions?
X minus 4 and 4.
Right. X equal 4 and x equal minus 4. Well, now there was a different way to do that. I can actually solve this quadratic by moving the 16 to the other side like I was solving a regular normal linear equation. How do I solve this once I get it like that? Take the square root of both sides.
Okay.
When you take the square root of that, you get x, which is what we're looking for. When you take the square root of that, you get plus or minus 4.
Okay.
Notice that minus 4 works. When I take minus 4 and square it, I get 16. So we can't ignore that solution, the plus and the minus part. Well, if I used the difference of squares to factor it, I wouldn't make this mistake. 90% of my students leave this plus or minus out. But if I do it this way, I automatically get it. My solutions are x equal 4 or x equal minus 4. So I get both my plus and minus solutions, and there's no way to make a mistake. So when you have a quadratic that's a difference of perfect squares, I would always recommend factoring it a minus b times a plus b. Okay? So tell me how this factors. There's an x squared term. There's no x term. That's a perfect square, and that's a perfect square. So we have the difference of perfect squares. So what is it?
2x minus 3.
It's always the square root of that.
Okay.
And then the rest of it, you don't even need to work at. It's always the conjugate. 2x plus.
Yeah.
Okay?
Okay.
All right. So I think you got difference of perfect squares down, maybe. Do this one. It's a little harder to recognize because most of us don't recognize 1 as a perfect square, but it is.
Okay, x minus 1 and x plus 1.
Perfect. All right. Let's go back and factor some quadratics that may or may not factor nicely. In other words, my book doesn't even tell me that these necessarily factor nicely. We're supposed to find out. In other words, my instructions are factor it, and if it can't be factored, say so.
So 2x and x
My signs?
plus and plus.
What's my third step? Say it out
Find
loud.
the factors of 3 that add to make 7.
No, you can't do that. Remember I said all those nice, I tried to trick you right there. I said all those nice little rules like that no longer apply when you have a coefficient that's not 1.
Oh.
So we're left with trial and error. But there's not a whole lot of trial and error. There's only 2 factors of 3, 3 and 1. So either it's 3 and 1 or it's 1 and 3. Is it 3 and 1?
I think so.
Well, don't think. Check it. Check the middle term by doing the 2 smiley faces.
So 3x and 3x. No, I think it's 1 and 3.
Exactly. Because now it's plus 1x plus 6x adds to 7x. So this does factor into those 2 numbers. Okay. Find another one. Doesn't matter whether it's x. It can be any letter you want. It's still a polynomial, and it still can be treated exactly like it was x. I'm just going to use a different letter. Goes here and here. Julian, what goes
Okay,
here? Here and here.
2k and k.
What would that multiply together to be?
3k.
No, if I were to put 2k and k, when I multiply these 2 together, it's got to equal this, and that doesn't.
Oh.
How about that?
Yeah.
Okay. What are my signs?
Plus and minus.
Opposite.
Minus and plus.
No, in other words, this tells me that the signs are opposite. The only reason I prefer the word opposite as opposed to plus minus, because I don't know necessarily that it's plus minus. It could be minus plus.
Yeah.
Just know they're opposite. And I have to allow for both because I have a different number here than I do there.
Okay.
What's the next step?
Um,
Find factors of this. That's the next step. I can't apply any rules. I can't say factors of 11 that add to or subtract to 32 anymore. The third step when you have this situation is merely find the factors of the constant. Because this one, there's not very many. It's 11 and 1, or it's either 11 and 1, or 1 and 11, or 11 and 1, or 1 or 11. It's one of those three possibilities. Does this one work?
No.
Well, let's switch the 1 there and put the 11 there. Does that one work?
I don't think so.
It does.
Oh, it does.
No, you're right. Excuse me. And it also highlights a very important thing. This is plus 1k. This is minus 33k. Add them together, you get minus 32k. Well, that's not the middle term, but it's the right number, wrong sign.
Yeah.
So when I get that, all I have to do is move these down to the opposite sign. In other words, put the 1 on the negative and the 11 on the positive.
Yeah.
And now that has to work, because the inside is going to be minus 1k. The outside is going to be plus 33k. Add them together, we're going to get plus 32k. Yeah, that works. Okay? Getting the hang of it, kind of?
Yeah, somewhat.
Doesn't seem so hard, though, does it?
Yeah, not really.
Now, I am giving you extra hard ones here. In other words, these are ones you wouldn't normally get in Algebra 1, I think. I don't know for sure, because I'm not in your class. But this is never going to be useless information. You're always going to need to know how to factor. And in fact, the better you are at it, you're so much advantaged over everybody else. So if you can figure out the secret to factoring, you've learned a lot. What goes here and here?
7x and x.
What are my signs?
Minus and plus.
Or plus minus.
Yeah.
I have to account for both. What's my third step?
Find the factors and find multiple. Yeah.
Just find the factors of that constant.
Yeah.
There's only 2 of them. Now the fourth step is trial and error. That's the fourth step. Trial and error.
Okay.
Let's just start right off with 3 and 1. Does that work?
Yes.
Yeah, right off the get-go it worked. Well, what if I hadn't been so lucky and I would have tried 3 here and 1 there? Notice that doesn't work, but it does produce the number 4. It just produces a plus 4.
Yeah.
So when you find that you've produced the right number, wrong sign, all you have to do is switch the signs on the numbers you have. Move the 3 up to the plus, the 1 up to the minus, get rid of these. There's your answer. All right. With our remaining 5 minutes, see how your arithmetic is. As fast as you can.
3. 2, 7, 8.
Remember, when you're done, your answer times the bottom number has to multiply to the top number.
Oh, yeah, 4. 9, 8. 4, 3. 4, 8, 12. Is it 8?
Is 8 times 4 24?
No.
Is 6 times 4 24?
Yeah. 2. 4. 4. 9.
Remember the rules on 9. When you multiply 9 times a number, the result always adds to 9. 63,
Yeah.
6 plus 3 adds to 9. So whenever you see a number that adds to 9, know that one of the factors is going to be 9. In other words,
Okay.
what we're really doing here is finding factors of 63. They are 7 and 9.
Yeah.
Okay? This one?
9.
Well, one of the factors is 9, but not both of them. 9 times 9 would be 81.
Is it 4?
Yeah. Notice that factors of 36 are 9 and 4.
Yeah.
Okay. Let's do some multiplication. Go.
12, 30, 16, 81, 12, 36, 36, 32.
You are much, much, much better, Julian, than you were the first time I saw you.
12.
I don't know if you've been practicing on your own or what, but your arithmetic skills are better, a lot better. And that's huge.
Yeah.
You cannot advance in math with poor arithmetic skills. You just can't do it. It's impossible. So you have to get those good, and you have. So, cool. All right. We're at the end of the hour. Let's wrap it up. But very good. You've learned some math that is probably beyond what you're doing in class, and definitely I'm seeing progress.
All right.
So good on you. Talk to you
Okay,
next
thank
time.
you.
Talk to you
All
next
right.
time. Bye-bye.